Okay, so why does armature current depends on flux in series connection but not in shunt connection? Okay, so armature current depends on, because first of all we see that Ia is directly proportional to EB. EB is directly proportional to flux. So I can say flux is directly proportional to Ia. Okay. Now torque is proportional to both flux and Ia. So torque is proportional to I squared. But here Ia, basically it is not Ia but If. But for understanding purpose, I am writing it here. Ia is directly proportional to V, that is source voltage, which is constant. Now torque is directly proportional to phi Ia, so torque is directly proportional to Ia. Now this was starting characteristic of DC motor. Now we have running characteristics of DC motor. Okay, so what does running characteristic? Once the DC motor starts running, its performance is analyzed using its running characteristic, which include speed. Okay, so this is back EMF, this is speed equation, or this is simply the same thing, that is EB equals to K phi N. We have studied this in starting characteristics also. Now putting the value of EB from here to here, torque equation is still the same, P phi ZAI by 2 pi A. Now here we have a new thing, mechanical power, input power. So the power that we got from motor is back EMF into Ia. So what is the back EMF? Back EMF is, I guess I wrote here what is back EMF. Okay, yes. So back EMF is produced due to armature, motor armature. Okay. Motor armature. So this is the energy that we get output. Output energy. Input energy. This is the formula of efficiency. So if I do this, then I get efficiency equals to EB by V into 100. This is what I get efficiency formula. Now running characteristics, these are the 4 characteristics. Okay, so we have now 3 graph, torque versus speed graph. We cannot derive this graph, but I suggest you to learn it. For DC shunt motor and induction motor, this is linear. For DC series motor, this is hyperbolic. Now we have speed torque equation of shunt motor. Yes, as I said, the shunt and induction motor follow this pattern. So as we increase the resistance, our speed torque graph gets more positive. Okay, not speed but the tangent of speed torque graph gets more positive as we increase the, what I said, this, okay, resistance. Okay, so as we increase resistance, So this is the speed torque characteristics of series motor. Here also I can say that as we increase the resistance, the graph gets behind. Right, for trick I should write graph gets behind or near origin, whatever I said this earlier also. So these are the diagrams for motors. Like this is series motor. One thing it is sure that the resistance is always going to be in series with the motor. It's about the inductor. In compound, both series and parallel inductor is there. We have a speed control of DC motors. So the speed of DC motor is given by this fundamental speed equation. So there are two methods of speed control. That is one field control and second armature control. So field control, in the field control, series parallel control. Diverter field control, tapped field control, series parallel control, and this is shunt. So when we see the shunt, is it the same? I guess so. Yeah, it is same. Armature MMF be much higher than field ampere turns, resulting in unstable operation. So wait a second. So these are the methods for shunt motors. These are the methods for series motor. Field rheostat, that is this method, and tapped field control, this method. For series, we have this three methods: series parallel control, diverter field, and tapped field control. Okay. Now we have armature control. So for series motor, for shunt motor, and for series motor. So we can also control the speed using the from speed torque equation. We know that we can control the speed using resistance also. So we are going to control the resistance here. Next is voltage control, electronic control. So let's ask ChatGPT only what is voltage control method of speed control. the next thing, electronic control. Okay, so if these are not given, then maybe it was not necessary. Now we have got braking. So till now what we have seen, we have covered our starting characteristic, running characteristic, and we have also covered our speed control. Now we have our last electrical characteristics. We have our last, that is braking. Then we will move towards the mechanical, I guess. These are again the same thing that we have studied till now. So braking. What does braking states? Electrical braking is used to stop or slow down a DC motor by quickly converting its kinetic energy into electrical energy. It is commonly used in a okay, so electrical braking is used to stop or slow down DC motor by converting its kinetic energy into electrical energy. There are three types of braking, that is one regenerative braking, second dynamic rheostatics, third is plugging. So what we do in regenerative braking, the back EMF becomes greater than supply voltage, causing the current to flow back to the power source. The kinetic energy converted into electrical energy is returned to the supply. So in regenerative braking, I should write something here so that regenerative braking, what happens? I back to source as motor act as generator and EB becomes greater than voltage. This is regenerative braking. Okay. Second is our dynamic. The motor is disconnected from the supply and connected to the braking resistor. That is the motor. Maybe I should write here dynamic or rheostatic braking. What happens here? The motor is disconnected and connected to the braking register. Okay, simply remove supply, add resistor, and slowly the back EMF will decrease due to speed. Back EB decreases as speed decreases, hence IA also decreases. This is the external resistance. Now we have heard, that is plugging. Simply change the polarity of battery. Simply change the polarity of supply voltage. So the armature rotates in opposite direction, thus stopping it. Simple. Now we have different methods, not we can, but we have different methods. These were just an intro. The main thing starts here. How we are going to do plugging with DC motors. Let's study plugging with DC motor. What I have explained plugging just right now, that plugging is simply we change the polarity of the supply voltage. Okay, so how we are going to change the polarity of the supply voltage? First we can see here that this type of polarity here, it is going like this. This is shunt, this is series. Okay, so this is going to convert in this way, this is going to convert in this way. So how is series going to convert? We take the wire from here and connect it here, and we take the wire from here and connect it here. Simple. We remove this part of wire and we change the connection. Simply we change the connection with this. Okay, this is how we change the, and simply here also what we did, we took this one here and we took this one here. Okay, armature connections are reversed. At the instant of reversion, V plus is applied across the armature. V equals to EB minus IARA. This was the formula. I guess here it was plus. Hmm. EB equals to, yes, here it was plus. V equals to EB plus IARA. And what we get, IARA equals to V minus E. As soon as we change the supply, this converts to plus. Okay. Now EBT equals to K phi IA. This is torque, but I here equals to this, so this equals to this. So now the equation becomes like this. In case of series motor, phi is proportional to I and the value cannot be determined using magnetization curve, and value can be determined. Phi is for shunt motor, phi is constant. In case of series motor, phi is proportional to I. This is the whole thing. Now what is rheostatic or dynamic braking? We simply apply a resistor parallel to the thing. So here also we changed the polarity. I don't know why, but we changed. Okay. So what we did, we simply removed the power supply. And we removed the power supply. The whole thing is removed from here. And the remaining this part is connected across a resistor. Similarly here, this whole part is connected across the resistor. Okay, this is in case of shunt motor, this is in case of series motor. Supply is gone, so now V is gone, so we have only one turn. What is regenerative braking? That we simply convert it to generator. we see as here current increases, speed decreases. E is made greater than V. This is easy, not very difficult. This is so we converted this to this. And in series motor, this is not possible under normal conditions. So maybe I should highlight this point. Why is it like this? Is not possible. Okay. So I should also write here that regenerative braking is not possible in case of DC series motor. Now we have to study control of DC motors. Now we will study method of series parallel connection. So series parallel method of starting is not only efficient but it is. So what is this first of all?